In this short video, we are going to discuss about the statement of division algorithm for integers. So let me just write the statement. So I'm going to take a to be a non-zero integer and b is any integer. So b can be 0. So b is any integer. Then I'm going to divide b by the non-zero integer a, and when you do this division you do get a quotient and you get a remainder. So then there exists integer q and r. Q is an integer, r is also an integer, so we can find two integers, q which is called as quotient, r which will be called as remainder, such that dividend is equal to divisor into quotient plus remainder. This b is called the dividend, this a is called the divisor, q is the quotient, and r is called as the remainder. So this means dividend b, in my problem my b is the dividend, b is equal to divisor, divisor is a into q, quotient plus the remainder. I mean to say that b is nothing but equal to aq plus r. Okay, so this is what when we do the division. So we will now divide the number 42 by 5, and then we know that 5 8's 40, and the remainder comes to be 2. And now if you observe this remainder is less than the divisor 5. So the remainder can be 0, right? For some examples, the remainder, if I divide 40 by 5, the remainder can be what? The remainder can be 0, right? Instead of 42 or 40, if I take 44, then the remainder in that case will be 4, right? So remainder is actually greater than 0. It can be 0, it can be 1, it can be 2, it can be 3, it can be 4. But remainder cannot be 5, because if I take this 45 and if I divide it by 5, then I'm going to get 5 9s are 45, and then the remainder will turn again to be 0. So remainder for 40 is 0. For 41, when I divide by 5, the remainder is 1. When I divide 43 by 5, the remainder is 3, right? 44 it is 4, and for 45 the remainder is 0. So I'm getting the remainder will always lie between what? 0 to 4. It will never become 5, or it will never become greater than 5. So this remainder certainly has to be less than 5. Who is 5? 5 is the divisor. Okay. So the remainder is always less than the divisor, and it is greater than or equal to what? It is greater than or equal to 0, where 0 is less than or equal to remainder is less than the number a. So this is a statement for division. I'm assuming that the number a is what? The number a is positive. If the number a comes out to be a negative number, then this a is usually replaced by what? It is replaced by modulus of a. Okay. So for the time being, let us assume that I'm dividing by a positive number. So I'll just simply write it down as just a, where I'm assuming that a is a positive integer. Okay. This is the actual statement of the division algorithm. So you have to remember this particular box. So what am I going to do? I'm going to divide the integer b by a, and then we are going to get a quotient. We are going to get a remainder. Okay. And we can connect all the all the four people, dividend, divisor, quotient, and remainder using this particular formula. And then you'll get that b is equal to aq plus r. Okay. So having known the statement of the division algorithm, now we are going to solve a simple problem of integers. So if you see one simple example, let me just take one simple example, and then we will actually solve one problem which is based on division algorithm. Okay. So if you take any number in your mind, so let me choose the number, say, suppose 31. In other case, let me choose the number to be 44. Okay. Let me choose another number to be, say, 29. If I choose 30, these are the different numbers that I'm choosing in my mind. Okay. Then I'm taking, say, 14. Okay. So any number, if I divide, see this number 31, you can write it as 3 into something, 3 into something plus something, 3 into something plus either 1 or 2 or 0. Okay. So how can I write 31? 30 I can write as 3 into 10 plus 1. So it is like this. How can I write 42? Now we know that 42, 44 is nothing but 7 into 6. 7 6 are 42 plus 2. So this is nothing but 7 into 3 into 2 plus 2. So this is 14 twos. 14 threes are 42 plus 2. So it is nothing but 3 into 14 plus 1 plus not 1 plus 2. Okay. 3 into 14 plus 2. So this is the something number here. Here, this is the unknown number boxed. Plus 29. Now we know that 9 threes are 27. And we can just add 2 in that. So this is 3 into 9 plus 2. So this is again 3 into something plus 2 format. This number is also 3 into something plus 2. This is also 3 into something plus 2. First number was 3 into something plus 1. What is 30? 30 is 3 into 10. So this is 3 into something plus 0. It's the last case. What is 14? 14 we know we can write 3 4 the 12, and 12 plus 2 is 14. So this is 3 into 4 plus 2. So this is of the type 3 into something plus 2, right? So you take any number, you can always write it in the fashion of what? 3 into something plus 0, or you can write 3 into something plus 1, or 3 into something plus 2. Okay, I have taken 5 examples for you, and in every case it is either of this type, it is either of this type, or either of this type. 30 was of the type 3k plus 0. 31 was of the type 3k plus 1. 44 was of the type 3k plus 2. Similarly, 29 is of the type 3k plus 2, and 14 is of the type 3k plus 2. So any number will fall in one of the three categories: 3k plus 0, 3k plus 1, or 3k plus 2. Okay, this is the exercise we want to actually now solve. It's a very easy exercise. It's a 2-minute exercise. So let n be any integer, then n is either of the form, so that n can be written as n is 3k or n is 3k plus 1 or n is 3k plus 2. That is k is some integer. Okay, so in the previous example, who was a k here? Yeah, k was 10, k was 14, k was 9, and so on. Okay, so now what I will do is I will take this integer. So let n be an integer which is given to us, and this integer we are going to divide by which number? Which number we are currently discussing? Number 3 is coming in the picture, you see. So I'm going to divide this n by 3. So divide n by 3. Obviously, this 3 is a non-zero number, so I can apply division algorithm. If you remember what we have discussed in the division algorithm statement, that dividend is equal to divided into quotient plus remainder, right? So by division algorithm, we can find a quotient, and after doing the division, we can find the remainder. There exists means we can find a quotient which is an integer, a remainder which is an integer, such that what is the connection between all the 4 people? N, 3, Q, and R. Dividend is equal to divisor into quotient plus remainder. Who is the dividend in the problem? N is dividend in the problem. So N is equal to divisor. Who is the divisor of our problem? 3 is the divisor of our problem. 3 into quotient Q plus the remainder means N is basically 3Q plus R. And now if you remember the statement of division algorithm, this R had some limitations. This remainder we have seen in the statement that it is always smaller than 3. But the remainder can be 0 also. So some cases the remainder can be 0. So the remainder should lie between what? Which two numbers? It should lie between 0 to 3. It cannot be equal to 3. We have seen in the above example when I just defined the statement of division algorithm, right? When I just stated it. So the remainder is greater than or equal to 0 and the remainder is strictly less than 3. So this means what are the choices of R? So what integer you can think of which is greater than 0 and it is less than 3? So remainder can be 0, remainder can be 1, remainder can be 2. Remainder cannot be 3 because remainder has to be less than 3, right? So this means that when I put this value of R, we have 3 choices of remainder. When I have R equal to 0, when I have R equal to 1, and when I have R equal to, so these are the only possibilities of the remainder, right? In that case, what will this n equal to 3q plus R start looking like? How will this value 3q plus, let me show, where is 3q plus R? This. How will this 3q plus R start looking like? What will happen to this 3q plus R? N is equal to 3q plus R. So what will this become? This is 0. So this will mean that n is equal to 3q, right? And the next part R is 1 means n is equal to 3q plus 1, and because R is 1 and n is equal to 3q plus 2 because the value of R is equal to 2, right? So we are getting 3 different possibilities of n. This n is 3q, this n is 3q plus 1, or n is 3q plus 2, right? But what was n? What was n? N was n was just n was just any type of integer, right? So n was any integer. So this means that if you pick up any integer, you have eventually proved that, you finally proved that n is either 3q, or it is 3q plus 1, or it is 3q plus 2. So do you see that we have actually proved our exercise? What was our target? We wanted, we in this example I told you, you pick up any number, that any number is either of the form 3k plus 0 means 3k, or 3k plus 1, or 3k plus 2. And that is what we have done here. We have taken any integer and we have proved that that nat that integer is either of the type 3 into something, 3 into something plus 1, and 3 into something plus 2. So this actually finishes our simple application of a division algorithm. In the next lecture, we will see some more applications of division algorithm.